Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, this is the second numerical that we are going to do for the how can we calculate the number of moles of a particular substance. So let us do it. So this is the second numerical but of different kind. So in this case we don't have to find out only the number of moles, but we have to calculate something else also. So let us see the question and let us observe that what are the given data that are being given to us. So the first thing is they have asked that we have to calculate the number of moles and the number of molecules which is present in 500 milligram of carbon dioxide. So the first thing is, suppose they have mentioned the carbon dioxide in, they have not mentioned in a molecular format, but the thing that we should know is we should be able to write the molecular formula of the carbon dioxide. So the first thing that I am going to do is, the molecular formula of carbon dioxide is, I would write it in this way, that is CO2. So once I have got the molecular formula of carbon dioxide, so it would be very much easy for us to calculate what would be the molar mass of carbon dioxide. So how can we calculate? It is very much easy. So the molar formula or the molecular mass of the carbon dioxide will be nothing but I could differentiate in this format, that is carbon plus again oxygen and plus again oxygen. So the now I have been distributed into atomic format. Okay, so now I could write in a very easy thing, that is the molecular weight of the carbon is nothing but 12 gram per mole, while that of the oxygen is 16 gram per mole, while that of again there is oxygen, so again it is 16 gram per mole. So if I calculate this, or if I sum up all these numbers, so the answer that I could get is, it is 44, but since it is molar mass, so 44 gram per mole of carbon dioxide that we have got. So I could write it in this way, that is molecular mass of carbon dioxide, that is CO2. So this is what I have calculated, the molecular mass. But the weight, that is the mass of the carbon dioxide, is also being mentioned. So I have to write in a gram format because they have mentioned in milligram. So the first thing that I have to do is I have to convert into gram. So the mass of carbon dioxide, in this case what I would write it as the weight of carbon dioxide. I could write it in this way also. The weight of carbon dioxide that has been present, that has been given as 500 milligram. So I could write it as milligram in this format, that is 500 into 10 raised to minus 3 gram. Very much easy. So the first thing that we should be able to mention in a symbolic form for the weight. So we know that we could write in this way. So this is the weight of carbon dioxide that we have calculated, or we have converted into gram. So the next more challenging thing is, how can we calculate the number of moles? Again, we have the formula, that is number of moles, that is it is denoted by N. N is nothing but weight divided by molecular weight. And in this case, weight is been already given to us, that is 500 into 10 raised to minus 3 gram, while that of the molar mass, which was found to be 44 gram per mole. So therefore I'll divide it by 44. So let us see what is the number of moles of carbon dioxide we will get. So we have got 0.011 mole of carbon dioxide. So this is the one answer that we have calculated, but the another question that they have asked is, we have to calculate the number of moles which is present in 500 milligram of carbon dioxide. So as we know that 1 mole of carbon dioxide will contain the particle of 6.022 into 10 raised to 23. Okay, so 10 raised to, when we are talking about carbon dioxide, means which are, I'm talking about a molecule. So this much molecule of carbon dioxide will be observed if I calculate for 1 mole of carbon dioxide. So the number of moles of carbon dioxide that we have calculated for 500 milligram was found to be 0.011 mole, same of carbon dioxide. So suppose if this contains X particles or X molecules, if I would say. So it will be very much easy to calculate. We will do a cross multiplication so as to calculate it in a very easy format. So therefore, X will be 6.022 into 10 raised to 23, and I will multiply this into 0.011. So let us see what is the answer that we could get. So the answer that we have got is 6.843 into 10 raised to 21 molecules of CO2. So in this case, we have calculated two things. That is, when we are talking about 500 milligram of carbon dioxide, that means we are talking about 0.011 mole of carbon dioxide. And eventually, this means that we are saying that it contains 6.843 into 10 raised to 21 molecules of carbon dioxide. So this is how we have calculated the number of moles and the number of particles by using the Avogadro's number also, as well as we have calculated from the main thing that we are doing a numerical, that is the number of moles. So this is how we have calculated. So thank you friends for watching this video. I hope you have liked this video and you have understood this kind of numerical. So share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.